Okay, it is getting late, and I've been tackling this thing for quite some time now, so we're going to run through it. We are talking about the very first section in the next unit of study in your grade 8 year, and that is squares and square numbers, which fall under the unit of study, square numbers and the Pythagorean theorem. Now, square numbers and the Pythagorean theorem sounds like a complicated subject, but it really starts with the most simple things, things that you've talked about many times in your school lifetime. That's squares and rectangles. For the purposes of this unit, we need to make sure that we understand that there are some pretty fundamental similarities and differences between rectangles and squares. The first off is that all rectangles and squares are called quadrilaterals. The root of that is quad, and the basis of that quad is that each one of these has 4 sides. Also, another similarity between these is that they all have 4 90-degree angles. Which leads us to an interesting distinction between these two, because ultimately all squares are rectangles, but not all rectangles are squares. That's a little logic puzzle for you. The reason why all squares are rectangles, but not all rectangles are squares, is that squares have one characteristic that we really want to highlight in this first section, and that is simply the fact that their side lengths are all equal. So what does that look like? It looks like this. If we take our most simple square and we say that we have as our most simple square a measurement of 1 centimeter by 1 centimeter by 1 centimeter by 1 centimeter, we have one square. How we find out the area of a square is how we start stepping into the ideas of square numbers. The formula for the area of a square is side length squared, or length times length, or in this instance, 1 times 1. What that gives us is the square's area. And when we're talking about the area, there's two things that we have to have. A, we have to have a number, which in this situation would be 1. And B, we have to have a unit of measurement, which in this example would be centimeters. Now, centimeters, of course, has to be squared because we found the area, which means it has 2 dimensions. If we move up from there to the next square, what we'd be looking at then is a square that was, simply put, 2 centimeters by 2 centimeters. This is a perfect square, or a square, because it has all 4 sides as equal. Rectangles don't always have 4 sides equal. They don't have to. But in this example, we have 4 equal sides, which makes this a perfect square. So, our formula, once again, is S side length squared, which in this particular example is 2 times 2, which equals 4. And again, don't forget, we need to include our unit of measurement and that little squared symbol. So what that 4 is and what this 1 is are called perfect squares. Perfect squares are squares that have as one of their factors a number that when times by itself equals that number. So a perfect square is the result of any number times itself. So if we were to look at a list, we could go 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9. 4 times 4 equals 16. And 5 times 5 equals 25. All of these numbers, all of these answers are what we call perfect squares or square numbers. Now, what you really need to think about in this, because we don't always work in one direction, so we don't always go 2 times 2 equals 4. Sometimes you're going to be asked to find out what the square root of something is. When we're looking for the square root, we are looking for that number that when times by itself equals that number. So let's take, for example, the number 36. And we want to find the square root of 36. The square root of 36 is going to be found by identifying all of its factors and seeing if one of those factors is going to give us a square number. So we start off like this, 1 and 36. So 1 times 36 equals 36. Those are not the same number, so they are not squared. If we go to the next one, 2 times 18 equals 36 as well. Again, those are not the same number. 3 times 12 equals 36. Again, not the same number. 4 doesn't work. 5 doesn't work. 6 does work. And it's 6 times 6. So this is our final factor right here. So the factors for 36 are 1, 2, 3, 6, 12, 18, and 36. Now there's a neat little trick that you can use to identify whether or not a number is square by the number of factors it has. If a number has an odd number of factors, it is a square number. And the reason for that is that one odd one in the center, that one that doesn't have one that matches it, indicates the number that times by itself will equal 36, or the square number. So in this, we've found the square root of 36 by identifying the factors of 36 and finding that yes, indeed, there is one number that when times by itself does equal 36, which means that 36 is a square number. If you're given the number and you're asked to represent it in a shape or a picture that shows you that number, then you take as many little squares and piece them together to see if they form a square. Let's do that with the number 9. So if we take the number 9 and we make 9 little cubes, we know that we can arrange those cubes in different orders. So one way I can arrange them is by drawing a rectangle that is 1 by 9. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, there we have a rectangle that is 1 by 9. That is not a square. Is there anything that we can do that's 2 by something to equal 9? No. What's the next number? 3. So if we draw a shape that is 3, we have to multiply that by 3 again to equal 9. And if we look at that and finish that square off, we can see that it does actually make a perfect square because all of the sides are equal. So we know that 9 is in fact a square. Another thing we've found that's interesting is all of the factors of 9. So the factors of 9 are 1, 3, and 9. Again, let's remember that this odd number of factors proves to us that this is in fact a square number. that's as far as I need to go today on squares. When you come in to class and get going on the questions, this should give you an excellent start. And if you have any other questions, make sure you come up and ask me. It should free up some time. I'm also available at recess or lunch. Hopefully these get a little bit better over time, and hopefully I wasn't too boring. Ciao!